Okay, my dudes. One about pulleys now. First of all, let's just talk ourselves through what is a pulley, what will we be expected to think about when we've got pulleys, and all the rest of the fun stuff that goes around with it. So, what the hell is a pulley? Well, it's sort of like a wheel with a rope on top, and you've got weights either side. If you think about like the contraption you'll find on top of a well, I don't know what the hell I'm talking about, but in the like, has anyone ever actually seen a well other than outside of a storybook? But you know what I mean. More interestingly, it's two connected particles, a weight at either end of those particles. It looks like a bit like the picture that I've got in the middle to bottom left hand corner. You've got weights either side. They don't have to be the same mass. Of the diagram I've done, I've just made the masses the same just to keep things simple. Forces are acting on it. Forces are acting down, gravity, as we all know, and also tension is acting in the opposite direction. You see, tension is always going up, and that's generally the case with pulley questions. And tension is often a thing that you're going to be asked to find. Um, Gravity is 9.8, not 9.81, and that's a thing to remember, all of you physicists. You will lose marks if you use 9.81. I say there's no friction in year one, there is, sort of. There's certainly none of that business about working out friction from coefficients of friction times normal reaction force. None of that. They will tell you explicitly if there is friction. They will tell you exactly how many newtons it is, so you need not to worry. And you can also ignore air resistance, right? So that's the worst they can possibly do to you. So it's not quite true that there's no friction, but friction appears, it's just another number rather than something that needs to be calculated in its own right with reaction forces and things like that. So I hope that makes sense. Um, let's have a look at a standard question which goes through all the kind of things you might be expected to know. Hopefully the introduction has made most of the things clear enough. If you're not fully sure, again, what a pulley is, it doesn't actually matter. If you understand the things you're asked to do mathematically for it, it's not the end of the world if you can't pull up a bucket from a well. It's not. That's not what mathematics is asking you here. To be sure, I'm not even sure why they bother asking you it at all, but there we go. Right here, so we've got this masterpiece here, and I'm legitimately proud of this. It looks brilliant, and then I poured some water on the bottom left-hand corner. But, like, it's really clear. So, yes, I'm quite happy with this, and I'm boasting about it now. What have we got here? So we've got two particles A and B. They've got mass 4 kg and 3 kg respectively. So 4 kilograms A, 3 kilograms B. They're connected by a light inextensible string. That means elasticity is not a problem, physicists, and for the rest of us, it's just a thing they say. Over a pulley. Generally, they will say smooth pulley because we want to discount friction. The particles are released from rest with the string taut. Why does that matter? It means that tension is constant throughout. Again, it's not something they're going to mess around with or change, but now you understand why they always say that. When A has travelled 2 meters, it strikes the ground, and that comes into later questions. So part A, find the tension in the string. First thing is you must draw a picture. I'm someone who believes in every shortcut in the book. If I don't need to do something, I won't do it. I've never kind of actually hesitated to draw a picture. Not for mechanics, it's just a thing that's useful. If you do draw the picture, you get something that looks like that. You notice the tension is equal, that's implied by the string being taut. You notice we've got the mass on there, and it's 4g and 3g, that's basically the forces that are dragging it down for each weight, respectively. 4g, remember g is 9.8, not 9.81. Once you've done that, you treat each weight independently. So the first one, we've got 4g minus t equals 4 times acceleration. Where's that come from? 4g is obviously just gravity. Minus the tension, which is going in the opposite direction, and that equals mass times acceleration. Acceleration we don't know yet. Similarly, t minus 3g equals 3 times a. Now, a question I get a lot is why make it the other way around? I say, well, the reason is quite simple. It keeps the force positive. If we did 3g minus t, t is clearly going to be larger than 3g. Okay, why is that? Because if you let that system go, the 4 kilogram weight will be going down, and hence the 3 kilogram weight will be going up. Yeah? So if I did it the other way around, one of these will be positive. The first formula, 4g minus e, that will give you a positive force, and the second formula will give you a negative force. I just don't like that, so I don't do it that way. Also, it's got the handy-dandy thing that if you add them together, the left-hand sides literally just become, the t's cancel, and you can just add the right-hand sides, and that's just comfortable. So you end up with something like, as we do here, g equals 7a, and we can work out a quite quickly. Remember, g is 9.8. I've said that several times. That's a common mistake, is to go, treat g as if it's a variable. And then, oh my god, I've got 3 variables and 2 equations, I can't solve this. G is 9.8. I've kind of had that discussion, I think, with people before, actually. The G's not G is not something that you need to kind of treat as anything unusual. It's just do it that way, it's just quicker. Once you've got what A is, you substitute in and you can find out what T is. Simple as that. Okay, that's part A done. Part B says, find the speed of A when it hits the ground. So it's a Suvat equation. I've only bothered writing SUVA because I don't need T at all. Travels 2 meters. Initial speed 0. Final speed is what we want. Acceleration is 1.4. We just worked that out. Do Suvat, you get the answer. Not hard. Part C is an interesting one. It says, find the highest point that B reaches. Now, obviously, as A falls, B rises. So you might think to yourself, well, logically, A's gone up 2, so A's gone down 2, B's going up 2. Well, that's sort of true. But like, when A hits the ground, that doesn't mean B is automatically going to stop as well, because the forces that are acting on it may have stopped, but B is still having a certain amount of velocity going up, and it's going to take a little while for acceleration, negative acceleration of gravity, to whittle that down to 0. So yes, it's going to travel 2 meters, but it's also going to travel some more distance as well, and we need to find that out again using Suvat. S is the thing we want to find out. U is the speed we got previously, 2.37. V is 0, because that's the place, that will be the velocity at the highest possible point, and this time acceleration is minus 9.8. A is not providing any force. Tension doesn't exist anymore in terms of, in this, it's not, nothing's pulling this thing up anymore. So it's just gravity, so minus 9.8. Run Suvat again, find out how much extra distance you get. You'd have 2 meters, it would keep going up for another 0.29 meters, and then it will start falling back down again. So the highest it'll ever be is 2.29. I hope that makes it reasonably clear. I'm going to try and get like a big picture so you can see everything at once. As I said, I'm quite proud of this little script thingy. I hope that makes sense to you. There are other things that can happen. Sometimes you have tables. That doesn't really change much. Even if it has got friction, all you do there is just put that into your formula at the stage A bit. And say, okay, I've got gravity minus tension minus friction. There are some weird examples with lifts. I don't think you need to trouble yourself with them this year. If you can find one, I'm happy to do a video of those. But in general, this covers the main concepts. And this method you can use is it seems to be quite repetitive. You often have to find the acceleration and then the tension and then do stuff with the question. It seems to be the format for the questions this year. Okay, so I hope that makes sense. And that's me done for today.